This video is about how calculus is tested in the IB exam. Let's look at guided practice 1. Consider the curve y equals 2x to the third power minus 9x squared plus 12x plus 2 for x is between -1 and 3. Sketch the curve for x is between -1 and 3 and y is from -2 to 12. When you are asked to sketch the curve, here is some rules. Normally 1 point for correct window. So when you sketch the graph, you have to set up the window according to the given domain and range. 1 point for correct shape with a smooth graph. 1 point for stationary points. Normally means maximum and minimum point. 1 point for intercepts. That means x-intercept and also y-intercept. Sometimes 1 point for ending points. And sketch the graph means you need to figure out the critical points and with the smooth graph. But when you are asked to draw the graph, you have to make sure it's an accurate graph. So you have to pay more attention to the word sketch or draw. First of all, we clear the memory. So second plus 712. Now I go to y equals. I put in 2x to the third power. Then minus 9x squared plus 12x. Then plus 2. For y2, we put in math 8, the derivative function. Here's x. This will be alpha trace. Enter, get y1. Here's x. Then you go to window. For the window, according to this given domain and range, I will change from -1 to 3. Then scale don't change. For the y, we do -2 to 12. And the scale, we don't change. Then we go to graph. First of all, go back to y and don't highlight y2. I only want to get y1. So again, you get this. This is the window. So when you sketch the graph, you have to set up this window. And we are looking for the stationary point, means maximum or minimum points. So we have maximum here, minimum here. We go to second trace. First of all, we go to maximum. So move to the left. We need a left bound. Enter. Then go to right bound. Enter. Enter. The x equals 0.999. Whenever we have more than 39, that means integers. So basically it's 17. Then I go to second trace again. Want to get the minimum. So here's the minimum. Move to the left side of this minimum. Enter. Then right side of this minimum. Enter. Enter. Your answer will be 2, 6. Then we need to get the y-intercept. For the y-intercept, I do trace 0. Enter. You will get the 0, 2. For the x-intercept, you will do second trace again and get 0. So left bound, enter, right bound, enter, then enter. You will get the negative 0.149. Remember 3 significant figures. I will show you find the ending point. Ending point here is -1. So press trace first. You put in -1, enter. You will get the -21. But on the graph, we didn't show -21 over here. Therefore, you can go to equation solver to find the ending points. Check 3. So we press 3, enter. Yeah, this is a show on this window. How you get this point, the ending point for this graph? You will make sure this y equals here the minimum of range, that's -2. That means I will put the y1 equals -2. So I go to math, equation solver, put in y1 plus 2, then enter. It will be negative, so I will just put the negative 0.5 estimate, then alpha, enter. You will get negative 0.274. That will be the ending point over there. This is the answer key to this graph sketched. Remember, you have to show the intercepts. You don't have to show the coordinates. But when you get the coordinates for the maximum, minimum, and intercepts, make sure it's accurate. And since the domain is between -1 and -3, there's no equal sign, so put the open parentheses. Now let's go to 1b. A teacher asked her students to make some observation about the curve. 3 students responded. Lydia said the x-intercept of the curve is between -1 and 0. Yeah, this is true because we got the 0 is -0.149. Rick said the curve is decreasing when x less than 1. Here is x equal to 1. You could say the graph is increasing, not decreasing. So Rick is wrong. For Paula said the gradient of the curve is less than 0 between x equals to 1 and x equals to 2. See, this is x equal to 1, here's x equal to 2. You could see the graph is decreasing, which means the first derivative is negative. The gradient is less than 0. This is true. Therefore, only Rick made an incorrect observation. Let's go to 1c. Find the value of y when x equals to 1. We can do the trace, then put the 1. We already got is 1, 7. Then 1d, find the dy by dx. Now let's go to 1d. 1d, find the dy by dx. Basically, it's a derivative. For the derivative, we use the power rule of a derivative. We got 6x squared minus 18x plus 12. For 1e, show that the stationary points of the curve are at x equals to 1 and x equals 2. Stationary points means the first derivative equals to 0. Therefore, I plug 1 into this derivative function. Then you get equal to 0. This is means show that at x equals to 1 and 2, the stationary points of the curve are there. For 1f, given that y equals 2x to the power minus 9x squared plus 12x plus 2, that this function equals to k has 3 solutions. Find the possible values of k. When you have y equals k, which means how many intersections decide the number of solutions. So we need to draw the number of intersection for this graph. So I will draw the horizontal line. You see, when I draw this horizontal line, and they only cross the graph at one point. That means we only have one solution. If I draw over here, this is a horizontal line. Then I have 3 intersections. Then we have 3 solutions. If I draw the horizontal line like this, you see you have only one solution because we have one intersection. So where we can get the 2 intersection from this minimum points, I draw a line crossing this minimum points. Then here's the maximum points. I draw this line cross this maximum points. You could see I have only 2 intersections over here and over here. Then this one is over here and also over here. Therefore, when this k between, this is a 6, this is a 7. When this k is between 6 and a 7, then there are 3 solutions. Now let's go to guided practice 2. Consider the function g of x equals bx minus 3 plus 1 over x squared, x not equal to 0. Write down the equation of interval asymptote of the graph of y equals g of x. We know that vertical asymptote line, you make a denominator equal 0. According to the given function, we only have x squared as a denominator. Therefore, we set up x squared equal to 0. Square root of both sides, we got the x equals to 0. This will be the vertical asymptote line. Now let's go to B. Write down g prime of x, which means we are looking for the derivative of this function. So we do each term, we do the derivative. Bx do the derivative, we get the b. 3 will be 0. Negative 2 drop down, then minus 1, you will get the negative 2x to the negative third power. So we change it into positive exponents. We got the b minus 2 over x to the third power. This will be the derivative. For the 2c, the line t is a tangent to the graph y equals g of x at the point where x equals to 1. The gradient of t is 3. Show that b equals 5. When you talk about the tangent, that means the first derivative. So we put x equals to 1 into this the first derivative. You will get equals to 3. We will set up like this. Then you work out the b equals and 5. For 2D, the line t is the tangent to the graph of y equals g of x at the point where x equals to 1. The gradient of t is 3. Find the equation of t. Remember when you have the function like this, because you have variable like bx minus 3 plus 1 over x squared, this b, you cannot put into graphing calculator. After you get the b equals 5, then you can use a graphing calculator now. So we go to graphing calculator. You will get, clear this. This one is a 5x. And minus 3 plus alpha y equals, enter. I need 1 divided by x squared. Since I need the equation of this t, that's the equation of the tangent line. So I quit. I go to alpha trace y1, that I plug in 1. This give you the coordinates. That will be 1, 3. So you are given the slope of tangent line is 3. But if you want to figure that out, also you can get like y2 of 1. Whenever you have more than 3 9, that will be integers. So we do the 3. This will be the slope of a tangent line. So the answer will be y minus 3 equals 3x minus 1. This will be the equation of t. You don't have to change into y equals mx plus b form because it's not required. Now let's go to 2e. Using your graphing calculator to find the x-intercept, you are given this domain for the 2f. Therefore, we go to this window. Let's change into this, -2 and 5. Then we have a -15. Here is a 25. For the scale, since I have 15, 25, you can put the 5 here. So you can sketch the graph this time. Remember the y-axis, this is a vertical asymptote line. So I need to figure out the 0. I do second trace 2. I need, this one is -2, so I the left bound, let's do the -2, enter. Right bound, you can do the -0.1. Then enter. You will get -0.439. That's your answer here. Now let's go to 2f. Sketch the graph of y equals g of x for this domain and a range, indicating clearly your answer to part E. So we need to figure out the 0 and also this minimum point. So let's do the second trace. Get the minimum. It's like 0.1, that's the left bound. Right bound, you can just move. And on the right side, okay, enter, enter. So you get, this is a minimum, it's a 0.737. Y will be 2.53. There is no y-intercept, but let's check the ending points. We do the trace, -2, enter. -51 over 4, it's shining here, so you can find in this window. Then we get 5. Enter. Yeah, it's shining here too. Then you can show these 2 points on your graph. For second part, they said draw the line T. Draw, that means you have to make it accurate. We do the trace 1. Then you will get the 1, 3 here. Then for the y minus 3 equals 3x minus 1, you can get the y equals 3x. So you have to use this origin, then connect 1, 3 to show the equation of a tangent line. Because this set over here is a draw, that means make it as accurate as you can. This is the given answer key to this graph. Make sure it's a correct window, correct shape with a smooth graph. You have this y-axis is a vertical asymptote line. And for the stationary points, that's you have minimum this point and also the x-intercepts. When you draw this tangent line, make sure it's accurate. So you have 1, 3 is here. This will be 0, 0. The tangent line will pass through these 2 points. For the 2G, using your graphing calculator, find the coordinates of local minimum point of y equals g of x. That is 0.737 2.53. Remember, answer must be 3 significant figures. For 2h, write down the interval for which g of x is increasing in the domain x between 0 to 5. You have to get the minimum value here. This is increasing. Therefore, the increasing interval will be 0.737 to 5.